after loading our setup, we've got a lane and an agent, and the agent walks, but he doesn't follow the lane because there's nothing in his brain to make him do so. So Alt R to reset, and let's put something in his brain. We start with an input node and type lane.x, a range of -1 to 1, and if we hit the spacebar again, let's see what happens. So we get a value for where he is across the lane, and that's useful. Let's put on a fuzz node, call it left. Another one, call it center. And right. And we can connect those, control click and control box select to connect all three at once. Now left should have a range of about -1 to 0, and it doesn't have to be exact. Center can have a range of -1 to 0 to 1, and right can be 0 to 1. Okay, and then what we want this to control is his turning, which would be RY, but we don't type RY because the action is controlling RY. So what we need to do is offset the RY channel in the action. We click action, we find RY, and offset. Now this is an angle, so let's set the range to -180 to 180, and the defuzz values should be left, straight and right. Left, straight and right. Now we connect those, control box select, control click. Now we need to set what these values are. So left is a positive rotation because of the way that animation space works. Right is a negative rotation, so we're going -90. Now we could connect these up to these, and if he's on the left side of the lane, it would make sense for him to turn right. If he's in the center, go straight, and if he's on the right side of the lane, perhaps he could turn left. And let's see what that does. So spacebar. Alright, he's turning, but I don't know if we'd call that following the lane. And the reason is that he's not paying any attention to the angle that he is in the lane. So let's copy this lot and paste it. Let's disable these with Alt D. Now let's change this to lane AX, which is the angle in the lane. And being an angle, we'll set the range to -180 to 180. Now we'll need to change our fuzz nodes, and in fact we'll change their names as well. So left becomes facing L, just so we don't confuse it with being on the left side. Center becomes straight, and right becomes facing R. Now, because this is an angle, left is a positive value, so we'll set left to something like 0 to 45. Straight is of course in the middle. We'll go -45 to got that wrong. There we are, 45. And facing right is a negative value, minus 45. Now, let's see what happens. Right, he does appear to be following the lane, but he's kind of drifting off the side. And now he's back in. So he's not responding to where he is across the lane now, which means we probably want to combine the values for lane X with the values for lane AX. So let's delete this because we only need one set of these. Let's enable these with Alt-E. Disconnect these with Alt-Control Box Select, Alt-Control Box Select. Now, what we want to do is have rules for all 9 combinations of the possibilities of these fuzz nodes. So let's call this one left, and we'll copy and paste that a couple of times. Let's do center, and right. Now we can connect all of the lefts together, the centers together, and the rights together, and then facing L to the first one of each block of 3, then straight to the middle ones, and facing right to the third of each block of 3. Now we've got all of the possibilities of the combinations of these fuzz nodes. Let's just move these apart a bit so we can see the connections more clearly. So when, let's give them better names as well. You don't really have to, but it makes it easier to read. This is left and facing left. This is left and straight. This is left and facing right. This is center and facing left. This is center and straight. This is center and facing right. This is center and facing left. Sorry, right and facing left. This is right and straight, and this is right and facing right. Now, clearly, if he's on the left and he's facing left, we definitely want him to turn right. If he's on the left and he's going straight, we probably want him to turn right. And if he's on the left and he's facing right, we could let him just go straight. Now, if he's center and facing left, we probably want him to turn right. If he's center and going straight, then he can keep going straight. If he's center facing right, we'll have him turn left. If he's on the right and he's facing left, we'll have him go straight. If he's on the right and he's going straight, let's have him turn left. And if he's on the right facing right, he definitely needs to turn left. Okay, let's see what we get now. He's doing pretty good. Okay, well, it looks like we've got him to follow our lane. Now, let's reset. What if we want him to go the other way? Well, let's bring on an output node and set it to lane.reverse and set the value to 1. Now let's see what happens. Well, that seems to work. And what that does is it flips the input values of lane.x, lane.ax, etc. so that we'll get the exact opposite behavior.